Okay, good morning, ladies and gentlemen. So yesterday we talked about complementary supplementary angles. Now we're going to start to talk about our vertical angle relationship. So when do we have vertical angles? When two lines intersect at a point. So thinking about the old school ancient mathematicians, right, they realized that they had these two lines intersected at a point. They had a really special kind of very simple relationship. And what they said was, or the way they figured it out, they said, all right, these angles look like they're the same, right? So maybe they're the same, and these angles look like they're the same, but they wanted to be sure. So they measured one of the angles, and they said, well, let's say that this was 150 degrees. And they'd say, well, this blue line here is a straight angle, so therefore this angle has to be 180 minus 150, which is 30. And this is a straight angle, so this angle has to be 180 minus 150, which is 30. And now I've got a straight angle here, so 180 minus 30 is 150. So given one of the angles, right, without doing any actual measurement of anything else, they were able to find out the others, and they were able to determine, and you'd really just do it algebraically, right? I'd call this x and 180 minus x and x and 180 minus x. But that's how they figured out the rule for vertical angles, that the angles opposite each other, which are these angles and these angles, they're the ones that are called vertical angles, and they're congruent. So angles 1 and 3 in my diagram here are equal, angles 2 and 4 are equal, and as I showed you, all I would need is one of these angles to find the rest. If I told you that this was 30, you'd be able to tell me that this was 30, and you'd say because it's vertical to angle 3, angles 1 and 3, and since this is going to be the supplement, we would do 180 minus 30 is 150, and we can do the same thing here. So what happens, right? So what do we know about these angles, right? 1 is equal to 3, 2 is equal to 4. Now the angles that are next to each other are called adjacent angles. So informally, right, if I said, what does the word adjacent mean in math? Someone would raise their hand and say it means next to, and I'd say, well, technically, yeah. But mathematically, common side and common vertex. So angles 1 and 2 share this side, and they share this vertex, so angles 1 and 2 are what we call adjacent. So are 1 and 4, so are 2 and 3, so are 3 and 4. So angles 1 and 2 together would add up to 180 because they make a straight angle. Angles 2 and 3 would add up to 180. Angles 3 and 4 would add up to 180. And then the other one that is left out is angles 1 and 4 would add up to 180. And if we add all three of them, they would make a full circle, which would be 360 degrees, right? Angle 1 plus angle 2 plus angle 3 plus angle 4 makes a nice full circle, which we should know from circle graphs and things like that, that a circle should be 360 degrees. All right, so this should be pretty easy then, right? So angle Z is vertical to the 110 degree angle, so we'll call that 110. And the other two angles are going to be supplements, right? Because we can consider either of these to be a straight angle. So there's my straight angle. So if x and 110 have to be supplementary, if they have to add up to 180, then 180 minus 110 should give me 70. And then to find y, I can do 180 minus 110 again, but that's a little silly. X and y are vertical, so they should both be 70 degrees. And we can do the same thing here. Angle B right off the bat is vertical, so it's 42. And we do 180 minus 42, which gives us 138. So the other two angles are going to be 138. All right, so now we have to consider, there's a bunch of different ways that we can do this. So the first thing I'm going to do is I'm going to consider this straight angle, and I'm going to say, how could I find y? I can do 180 minus 125, which is 55. And now I can do one of two things. I can say, well, x and y are vertical, right? And I normally explain this at the beginning of the lesson. I don't care how many ways that this is split up, right? If this is angle A, then this is angle A. If this is angle B, then this is angle B, angle C, angle C, angle D, angle D. So it's not just two lines intersecting at a point, right? It could be any number of lines. Now, if I consider this and this to be my intersecting lines, which they are, right? The thing between 35 and Z is just what's called a ray. That doesn't really have a bearing on my vertical angle so much, right? Then that would tell me that x should be equal to y. But let's say we don't believe that. Well, let me take this back. All right, we've got y is 55. Right, and again, I know for a fact, neglecting everything else, that this is a straight angle. So how would I find out x? 180 minus 125, which is 55, which kind of helps to cement the fact that I know x and y are vertical. Now what can I do to find z? Well, I can do it in a few different ways, right? And I'm going to do it simply by making this my straight line. So I'm going to think about that straight line. Now I'm going to say these three angles have to add up to 180. So I've got a 55-degree angle. I've got a 35-degree angle. So that gives me 90 degrees. That means 180 minus 90 should give me z, which is 90 degrees. Now, what's another way I can do it? Well, I could have used this straight angle, and I could have said 35 plus y plus z. And since y is already 55, the computation would have been the same. How can we check it? We can add everything up. We can add up our straight angle parts, right? X in 125 should be 180. So should y in 125. So should yz in 35. So should xz in 35. We could just add them all up. And when I add them all up, I would expect the sum to be 180, which the sum is going to be 180 when we add them all up. All right, now this one we're just going to use the vertical angle relationship until the end. So I would, I would say, all right, guys, so what's vertical? And someone would say 37 degrees in X, and I would say, great, 37. And I'd say, what else? And someone would say 102 in Y, and I would say, great. And I'd say, well, how are we going to find the other one? And someone would say, draw the straight angle, which we did. So WX and Y, or XYZ, or Z37, 102, any of those, any three angles here that are making up my straight angle have to be 180. So I'm going to say, well, what's 102 plus 37? It's 139. How do I find the missing one? I do 180 less 139, which is 41. And since W and Z are vertical, that would also be 41. And we can check it again by adding any three angles, three adjacent angles, or angles that are consecutive, I should say, and make sure they add up to 180. Or we can add them all up, and we see that the whole thing will add to 360. So there's your now try, which should take you all of about a minute. So you can pause, and you should be good to go. So we've got 107. If we want to find the other ones, we do 180 minus 107, which I'm sure we all will get 73. And same thing here. We know that this is 86, so we can do 180 minus 86 gives us 94. And we can check it real easily by adding up all the angles and making sure that they add up to 360. All right, and again, guys, this topic is not in the textbook, so all of our homework is going to be coming off the slides. So for your homework, you're going to sketch each of these and you're going to fill them in, okay? You don't need to show me any sort of, work. Or, if you want to show me subtracting from 180, you can. You really don't have to. So really all I need you to do is to draw these figures and fill in the angles that are listed, okay? In other words, I don't need this angle and this angle. I just want the angles listed. I want X. I want, for the second one, W. Here I want A, B, C, D, E, and F. And for the last one, I want A, B, and C. That should take all of about 5 or 10 minutes. And of course, guys, any questions or concerns, please send me a message.